With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, let's discuss the question. The integral of integration x cos inverse 1 minus x square upon 1 plus x square dx, where x is greater than 0, is equal to. So let's begin with solution of this question. So first we will just simplify this function. That is, if we'll write this integral as integration of x multiplied by this cos inverse this 1 minus x square divided by this 1 plus x square, and here this is a dx. So basically this is a complicated integration, that is we don't know the integration directly here, so we will just use the process of substitution, that is converting this question into a easy question, easy integration. So here we will just substitute this x equal to tan theta. So this x will be equal to this tan theta. So from here we can say that this dx will be equal to this, that is in differentiating this equation with respect to this theta we can say. So it will be differentiation of tan theta, so it will be sec square theta, and here this will be d theta because of respect of this theta. So this is value of dx. If we will just remind the formula, that is 1 minus tan square theta divided by this 1 plus tan square theta. So we can say that this is equal to formula of this cos 2 theta. So this is the formula of cos 2 theta. So if we will just substitute these values, that is x equal to tan theta, dx equal to sec square theta, d theta. So we get this as a I integration. So I will be equal to this, that is x will be this tan inverse theta from here. So tan inverse this it will be, x is directly tan theta only, so it will be tan theta here, and here this will be cos inverse. Here this will be 1 minus this x square, which is tan square theta. Similarly here this will be 1 plus this tan square theta, and here this will be dx. So value of dx we have already, that is sec square theta into d theta. So this will be sec square theta multiplied by this d theta. So from here if we will just simplify this I, so we get this as tan theta, and here this cos inverse, and here this formula, that is 1 minus tan square theta upon 1 plus tan square theta, that will be cos 2 theta. So it will be cos inverse of cos 2 theta. Here we get this as this sec square theta, and here this d theta. So finally our integration will be simplified to this, that is here this will be tan theta multiplied by sec square theta d theta. So we can directly write this tan theta, here this will be sec square theta, and here this is d theta. Here this cos inverse cos 2 theta, so it will come out to be 2 theta only. So this is our second, this first term, this is our second term we can say. So from here if we will just use the product rule of integration, that is we will just assume this function is the first function and this function is the second function. So we will just proceed like this, that is here the formula for this product rule will be like this, that is integration of, here this will be first function we can say first, and here this will be second function, that is 2, and here this will be dx. So the formula for this integration will be like this, that is first function multiplied by integration of the second function minus integration of differentiation of first function. So it will be d first upon dx, and here this will be integration of second function, that is second into dx, and here this will be whole dx. So basically we will just use this formula to get the integration of this. So here this is first function, so we can write this I, that will be like this, that is integration of this integration of second function multiplied by our first function. So we will just put a bracket here. So integration of this second function, that is tan theta sec square theta with respect to theta. So tan theta, here this sec square theta with respect to theta we are integrating, so we will just put a d theta here, and this integration is multiplied by our first function, that is like this. So this is our first function, that is 2 theta. So here this will be 2 theta minus, here this is minus sign, so we will just put a minus integration of this, that is a differentiation of first function. So here differentiation of this first function will come out to be 2, that is differentiating this 2 theta with respect to this theta. So we get here this is 2 multiplied by integration of this second function, and then a whole integration. So integration of this second function, that is integration of tan theta, here this will be sec square theta, integration with respect to d theta, and then again we will put a d theta here. So this is d theta. So basically this is the integration. So further we will proceed. So we get the value of I, that will be, so here this 2 theta multiplied by this integration. So here we can say that this tan theta is, if we will assume t here, that is this tan theta, if this is equal to t, then if we will differentiate this, so we get this as a sec square theta, d theta, that will be equal to dt. So directly we can integrate, that is a f dash x into fx. We can say the formula, that is a integration of f of x multiplied by this f dash x dx. So it will be like this, that is a fx power, here this will be fx, and if this is power n, so fx power this n plus 1 divided by this n plus 1. So basic integral formula for the general variables x and y we are using here, because this f dash x is present. So here this will be like this, that is tan square theta here, and this will be 2, that is integration of tan theta, assuming that it is a general variable. So this will be, and here this minus sign, here also it will be 2 into this integration, that is tan square theta upon 2. So tan square theta here, and here this will be 2, and here this is d theta. So from here cancelling this 2 with this 2, this 2 with this 2, so we get this I equal to this, that is theta into this tan square theta here, and here this will be this, that is minus integration of tan square theta. So we will just put this in terms of sec square theta, because we know the integration of sec square theta. So it will be sec square theta minus this 1, and here we will integrate with respect to d theta. So further we write the integration I, that will be like this, that is a theta tan square theta, and here this will be minus integration of sec square theta with respect to this d theta. So we can say that differentiation of tan theta is sec square theta, that we have did here also. So we can write this as minus tan theta, and integration of this minus into this minus, so it will become plus, and integration of 1 with respect to d theta, so it will be theta. So it is here, this is plus theta. So from here if we'll just put the value of theta, that will be tan inverse x, because here x equal to tan theta, so this theta will be equal to tan inverse x. So further we will add a constant c because of integration constant. So finally we get the answer like this, that is I equal to this theta, so it will be tan inverse x, and here also this theta existing, so we will just take this common, so theta common, so it will be tan inverse x common, and here this x, here this term will be this tan square theta, so it will be x square, here this will be theta is already common, so we can write this as plus 1, and here this will be minus tan theta, and here this is plus c. So finally we can just write one step more, that is putting this tan theta also in terms of this x. So what we get this as this I will be equal to this tan inverse x, and here this will be this 1 plus x square, and here it will be minus this tan, or we can say tan theta will be x, so minus x here, and here this is plus c. So if we'll just match the options for this, that is we have minus x along with this tan inverse x into 1 plus x square. So if we'll just check the options, so here there are 4 options, so here this is tan inverse x into 1 plus x square, and here also this is a minus x and plus c also. So we are getting this as an answer, that is this answer, this minus x and this tan inverse x into 1 plus x square plus c. So answer to this question will be option D. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.